Late 2025. The night sky is anything but calm. Giant comets are streaming toward the sun. 7 major objects are making their dive in just a few months. Their paths cut through the inner solar system almost back to back, all inside a single season. This isn't just a busy year. This is a swarm unlike anything recorded in the modern telescope. What will happen when they all rush through the sun's domain together? Most years are calm. A single bright comet might grace the sky, maybe 2 if you're lucky. Sometimes none at all. But this time the count is 7, and their timing is too perfect to ignore. It began quietly with C/2022 N2 Pan-STARRS, a distant object reaching perihelion on July 31st, far beyond Mars. Its faint glow was visible only to professional telescopes, a distant whisper of the season to come. Even so, its track marked the outer edge of a pattern no one expected. The first sign of what would become a storm. Then came C/2025 R2 Swan, the comet that set astronomers buzzing. It was discovered on September 11th and reached perihelion just 1 day later, an incredibly fast turnaround for a comet spotted so far from Earth. Swan is a fast mover, its geometry bringing it unusually close. On October 21st, it will sweep past Earth at just 0.25 astronomical units, roughly 37 million kilometers away. And that distance means its tail could appear huge, stretching across 2 or even 3 degrees of sky. For perspective, that's 5 times wider than the full moon. Early risers in the northern hemisphere could catch it before dawn, a pale sword of light cutting through the stars. The tempo keeps rising. On September 27th, 414p/stereo loops past the sun on a path that dips below the ecliptic plane. Because it passes so close to the sun's glare, ground-based observatories will struggle to catch it. But space missions like Stereo itself and SOHO's coronagraphs are perfectly positioned to image its journey. For solar researchers, this is more than a comet pass. It's a chance to watch how its material reacts as it dives through the sun's outflowing magnetic field at a steep angle. C/2025 K1 Atlas arrives next, and it is the one most likely to put on a dramatic solar show. Its perihelion falls on October 8th at just 0.33 astronomical units closer to the sun than Mercury ever gets. At that distance, its icy surface will sublimate violently, building a spectacular tail that could twist and shift from hour to hour. Researchers will be watching for sudden brightening events, outbursts caused by collapsing cavities inside the nucleus, and for the narrow ion tail that may be swept aside by solar storms. And then comes the true wildcard, 3I/ATLAS. Its orbit is not from here. Its path is hyperbolic, meaning this is its only visit. When it swings past the sun and heads back out, it will leave the solar system forever. Superior conjunction happens October 21st, when it passes directly behind the sun from Earth's point of view. And perihelion follows on October 29th, at 1.36 astronomical units, just within Mars's orbit. Its inclination is only about 5 degrees, meaning it moves through the same plane as the planets, side by side with the other comets in the swarm. Its coma, the glowing envelope of gas and dust, has already expanded to over 700,000 kilometers, nearly the size of Jupiter, and continues to grow as sunlight wakes up more volatile gases. Hubble and JWST measurements suggest its nucleus could be just a few hundred meters across, or as large as 5 kilometers. But either way, it is shedding carbon dioxide far more than water vapor, a rare trait that sets it apart from typical comets. For planetary scientists, every observation is a chance to compare its chemistry with that of our own solar system. And the parade is still not done. In early November, C/2025 A6 Lemon will light up the evening sky, reaching a brightness that might make it visible even without binoculars for observers under dark skies. Forecasts place it around magnitude 4 or even 3.5, which means anyone willing to find a dark horizon could step outside and watch its coma glow near the southwest after sunset. By December 19th, 240 P/NE will make its return, a periodic comet that may not grab headlines with its faintness, but is still part of the story. Proof that the inner solar system is more crowded at year's end than it has been in decades. Scientists aren't just watching for beauty. They are looking for physics in action. Every comet acts as a natural probe of the sun's invisible magnetic field. As a comet approaches the sun, solar radiation heats the nucleus, releasing gas and dust that form two distinct tails, a broad dust tail and a narrow blue ion tail. The ion tail in particular points directly away from the sun and is shaped by the solar wind. When a coronal mass ejection slams into a comet, the result can be spectacular. The magnetic field shifts, and the ion tail can be completely severed by a tail disconnection event. In April 2007, the Stereo spacecraft captured one of the most famous examples when a CME hit Comet Encke. The tail was sliced off in minutes, leaving a visible gap as the comet grew a new tail, aligned to the new field direction. With 7 comets arriving during solar maximum, the odds of seeing not just one, but several such events are the highest in years. NASA's CCMC modeling team believes the sudden influx of plasma could even disturb the heliospheric current sheet, nudging the sun into more frequent or intense eruptions. Others, like the Solar Orbiter and Parker Solar Probe teams, are more cautious. They argue that most disconnections are subtle, shaped by local turbulence rather than by massive CMEs. But all agree this is the best chance we have had in decades to study these interactions in real time. But just as the drama reaches its peak, Earth will be blinded. From early October through late October, the sun will swallow the entire scene in its glare. This period, called solar conjunction, will hide Swan, Atlas, and the others at the very moment they make their closest approaches. For astronomers, it feels like the universe is drawing a curtain across the most important act of the show. Only space-based coronagraphs like SOHO's LASCO cameras will be able to keep watch, streaming ghostly images online as these comets graze the sun. Astronomers and citizen scientists are preparing for this moment, booking telescope time and writing automated tracking software, even setting up live feeds so the public can join in. When the comets re-emerge from conjunction in November, they may look completely different. Some may brighten dramatically, others could shatter into fragments. And 3I/ATLAS, the interstellar traveler, will already be heading outward, beginning its eternal journey back into deep space. The bigger picture is staggering. The odds of 7 major comets arriving so close together are vanishingly small. Many years pass without a single naked-eye comet, yet now we have several, including one that doesn't even belong to this star system. Statistically, this is the kind of season that might come once in a lifetime, maybe once in several lifetimes. For the public, it means some of the most spectacular skies in decades. October 21st will bring Swan's closest pass, with a sweeping tail for pre-dawn watchers. Early November will showcase Lemon, glowing in the southwest after sunset. And for the comets too close to see, space-based instruments will provide a front-row seat to whatever happens near the sun. 7 comets, 1 season. A sky transformed into a stage for something we may never witness again. When the curtain falls, the inner solar system will never look quite the same.